So this lesson I will partly spend on again the pre-processing technique, and if time permits, I'll also cover the scaling laws in fluid mechanics and heat transfer, and how to use scaling laws in any different field. So the scaling law is not only limited to fluid mechanics or heat transfer. These rules can be used in any other field. Okay, and this is very useful. So please attend that session carefully. So we were there in the previous session. You are discussing about the mesh quality and how to overcome that. So to continue the session, first let me share my screen. Okay, so I hope my screen is visible.
Yes, sir. Visible, sir.
Okay. So I'll close this. Okay, so I was discussing about that in case of let's say a flow behind a cylinder, okay, or flow over a cylinder. So you have seen how vortices are being set, and to calculate actual the flow features, we need to be careful. Then what flow features we need to we are going to capture using machine. So here in this case, let's say this is the white color. Basically in CFD, wherever you want to model a solid, you just remove the mesh of the surface, so that will act as a solid surface. Okay, and the green one around this is the thickness of cylinder. Okay, I usually I saw that for conjugate heat transfer, but in this problem, since I am just focusing on the pre-processing part. Okay, so I will not bother about. So I'll assume everything above this white color is my fluid domain. Okay, I'll not consider as a solid domain or a conjugate heat transfer part here. So I'll see how we'll see how to model it. Now, one way I have seen many students doing the mistake in modeling such kinds of problem is they take a simple let's say a mesh size, arbitrary mesh size. You can have a quad, tria, or mixed. Okay, mixed is generally preferred when the geometry is complex, so it will capture the geometry in a better way. But doesn't matter as long as you maintain the proper quality of the mesh. So here, let's say if you select let's say a very coarse mesh. Okay, first of all, as I discussed earlier, that you are not capturing the cylinder. So instead of a circular cylinder, it's become a pentagon. Okay, so now see, you can increase the mesh size here. Okay, to make it perfectly cylinder, you can increase the further mesh size. So even if you, let's say, you are able to capture the, let's say, flow features near the surface, but again the flow feature behind the surface also is very important. Okay, so last class we also discussed how to capture the geometry near the surface, but away from the surface is also very vital. In a sense, here behind the cylinder you will see a lot of flow separation and shading of vortices. So this kind of mesh is not the correct way to do the meshing. Okay, so what I'll do is I will just delete this mesh. Okay, and I'll show you how to do. Now see, I have here in the previous class In the previous session, I talked about the feature lines, the green color. Now here you see I have deliberately cut this surface or divide this surface so that I can create these features line. You can see the additional green color. These are called feature lines, which I have made it so that I can select it in a proper way. Okay, so earlier it was a one surface. Okay, so I had no option to select these surfaces, so I just trimmed this surface, or I broke this surface into small surfaces, and these surfaces are green surfaces, and nothing but then the two surfaces are being connected. Okay, so the one way to do meshing is to just go and, let's say, refine the region. So if this is the region where you are likely to see, let's say, reverse flow, so assign a little finer mesh, and then the regions away from it can be, let's say, a little coarse mesh. Okay, now you can see I have assigned this region, the core region of it will mesh the system with one element size, and the further nearby surfaces it will mesh with element size 3, and the rest other I will mesh with a coarse element size. So the areas away from this and these lines is not that influencing. Okay, so you can return. Okay, so you can select a coarse mesh. Okay, okay, let me show you the try element. Okay, now see, now the region behind the wake has been refined. In a sense, this is very fine mesh, and slowly the mesh is growing to of size 3, and finally the area which are not that going to get influenced is coarse mesh. Okay, so this way you can optimize the mesh. Okay, mesh. Now here, even this mesh is not good in a sense. Can anyone say what is the problem with this mesh? Any idea? After a couple of lectures, you might have understood that where the mistake still there.
Boundary layer.
Mm-hmm. Yes.
So we need to make boundary layer.
Where?
Sir, around the cylinder.
Yes. So the cylinder, this green one, is basically it is my solid surface where the flow is likely to have a no slip condition. So there you need to refine more and more, or put a more boundary layer mesh near the surface, apart from the mesh which I discussed. Okay, so that is one way. Now one more thing, when many times the student do the mistake, these areas, this is a wind tunnel basically. Okay, so in wind tunnel the modeling strategy is like this. Let me show the PPT. Now see here. So before I go into that, so there is a general guideline. So whenever you do some external flow, so in this case, flow around the cylinder is a form of external flow. Okay, so instead of cylinder, it can be an aeroplane, it can be a car or anything. Okay, so the guideline here is how to you should make a flow domain is. So if L is the length of your model, and H is the height. Okay, so the rear side, or the side where this is likely to be shading of vortices, so it has, and it should be up to 1:4. It means the four times the L. This is just a thumb rule kind of thing, but it's not necessarily that it will be always 4 times the length. It can be lesser also, and it can be larger also. So how to check that one, whether you are taking the correct length of the domain or not? So without worrying about, just at the first instant, do the rough CFD model and do simulation and see till how far the downstream is getting affected. If you see it is extending beyond 4L, then you need to extend this rear outlet. Maybe it can go here. It again depend upon the flow behavior. Okay, and the height should be about 4 times the height of the domain, and width is 3 times. If it is taking a symmetry, so 3 into 3 is 6 times. And the purpose of taking this length is just to avoid the effect of walls. The top walls, bottom walls should not affect the flow, in a sense. So that's why we keep it a little far away. So in simulation here, then your wall should be far away. Then ideally, what should be the boundary condition? Let's say we're doing simply a fluid flow. Then for wind tunnel simulation, can anyone say that what should be the boundary condition on these walls? इस wall पे और side walls पे wall boundary condition क्या होना चाहिए?
Pressure outlet.
हाँ, थोड़ा जोर से बोलो, सुनाई नहीं दे रहा.
Pressure outlet on the top, sir.
Again.
Pressure outlet on the
On
top,
the top
of the. Yes.
No. If you're putting a, let's say, pressure outlet, then it's not a wall.
Oh, yes, sorry, sir. Yes, sir. Yes, sir.
So if you want to simulate a wall, ideally, what boundary condition we give on the wall? Anyone?
No slip condition, sir.
Yes. So, but here in this case, should we put a no slip boundary condition here? Why and why not?
No, sir, we can't.
No, it's not a question of can, but we should not be putting a no slip condition. The reason why?
Because of that's not the area of concern here.
So let's say if just in case, let's say if somebody is putting a no slip condition, so what it means is there will be a velocity gradient or a drag induced from that surface, as simple as that. So even if there is a drag or a velocity gradient on this surface, how it's going to affect the study? No, in no way. So simply way is to avoid that there should not be a drag. It should be a free surface. So just put a slip boundary condition, all the walls. Okay, so there you will see in the simulation there will not be any velocity. It will simply flow will slip over the surface without generating any shear stress. Okay, so because that wall is our main concern or area of. So I've seen many simulations people putting since they are not able to. I actually attended one conference in FD. Fluid mechanics, FMFP, fluid mechanics and fluid power in NIT Hyderabad, I think. So there was one person presenting a wind tunnel simulation with a lot of shear stresses induced on the wall. So I asked them then why you are putting this. Then he told, sir, you are not able to remove. He actually put symmetric condition there. Then I asked why you are putting this condition. He told that we are not able to remove this velocity gradient. That's what he was doing. Then I simply suggested just in the software, instead of no slip, make it a slip boundary condition. Mostly we have the habit of using everywhere no slip. But again, it all depends upon the problem at hand. Okay, no slip. Of course, if you put no slip boundary condition, it will be correct physically in a sense. But the problem at hand doesn't demand to put those kind of boundary condition on the wall. Okay, so you can apply a no slip boundary condition. Now again, one more reason that why this wall, the rear wall, if there is a, let's say, a reverse flow like this near this region. Okay, now ideally at the outlet you may put a, let's say, a pressure outlet boundary condition maybe, or something related to the pressure. And since the flow is recirculating here, okay, so what will happen physically, it will tend to drag the outside fluid inside also. So in CFD, you will see sometimes it will say that a reverse flow happening. And it's not only wind tunnel, there can be many situations where we do the simulation and we see at the outlet there is a reverse flow. So in that case, when we used to face a problem in the industry while modeling the engine and other things, you also used to get a lot of reverse flow there. So you have to, how to solve that one? You have to extend not only the sake of flow also, but also for the convergence issue. So if there is a reverse flow and that surface is having a fixed boundary condition, so then the software or the physics of the flow will try to maintain the same pressure because you have imposed externally a fixed pressure. And in the process of maintaining, because since it's not possible because of the reverse flow, maintaining a constant pressure is not is very difficult. So this it will show a lot of divergence, a jitter in your residuals in the CFD flow. So what to do? You just extend the surface beyond the distance where the flow will be almost stable. Okay, and there if you fix the boundary condition of whatever you want to apply boundary condition, not only fluid boundary, there can be also other boundary conditions, atmospheric boundary conditions. Then only it is possible to have a converse solution when your outlet is free of any disturbance, recirculation zones and all things. So ideally, we should avoid to give a boundary condition, either at inlet, outlet, or any other surface where there is no disturbance. The flow is fully established, it's not recirculating. So otherwise, your solution will diverge. So artificially, you have to sometimes extend the domain beyond the actual or physical domain. That is also one of the aspect for dealing with the problem where you face a convergence problem. So you have to look that whether you have applied the boundary condition is physically correct or not. Okay, in this case, if you apply a boundary condition of constant pressure at just here where there is a reverse flow, then that boundary condition, though it is correct as per your problem, but it is not physically correct because you are applying you are imposing a boundary condition on the entire wall, a constant pressure which the physics of the flow is not allowing because of the lot of recirculation, and because pressure will drop there because of lot of mixing, or sometimes it will have different behavior. Then software will not be able to get a converse solution. So even that is also one reason of where you're not getting the correct result or getting a diverse solution. So even if your mesh is correct, your equations are correct, even in that case, you will get a divergence or an inaccurate result just because the location of your boundary is not correct. Location in sense, there is no, except the object, these lengths are just arbitrary length. Where what you want to say is, this is a wind tunnel or 4 walls, where the walls have no role to play on the flow behavior by the obstacle. Okay, so you should place it far away, number one, and far away, so the walls will not have an effect, and the flow also will not have effect. So this is how you should deal with in applying the proper boundary condition. Okay. So here in all these walls, top wall, since this is a 2D problem, so this top line and bottom line, ideally you should be giving a slip boundary condition. And this length, the ahead of, because just in front of the cylinder, because the fluid will strike, and tend to bend a little bit. So you should give a length of how much it's given, 2L. So here 2L. Again, depending on the flow, if the flow is in the region of, let's say, Mach, there is a shock waves and all things. So this length may increase because shock tend to propagate and it have a bend like this. So you may have to provide have a geometry where just hold on, I'm getting an important call. Okay, so this is how the mesh has to be done. Okay, fine. So any question before I move to next? Hope it is clear in applying proper boundary conditions and also dealing with the artificial geometric extension to apply. So that's total boundary condition can be applied. Okay, so let me move to the next. So there are a couple of things which I like to tell. Now the same problem here, I discussed. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay, fine, thank you. See this one, as I said, I'll just quickly in another 5 minutes I'll finish it up because I have to deal with a lot of. So last class I told your mesh distribution should be based upon the flow behavior. So initially, if you have any geometry, when you get it, you don't know what kind of mesh and where to refine and where not to refine. So there is nothing to worry. Just arbitrarily at the first step, draw a mesh. Just run it with applying suitable boundary condition and see how the flow behaves. So in this case, in the geometry, as I said, in the first instance, many will mistake by thinking that flow will go there like this, as I मैंने कल बताया था, and it will behave and come out like this. But if you think that and start doing meshing based upon this, then that is not the correct strategy. So what you should do is, don't worry about the quality of mesh, don't worry about the number of mesh, don't worry about the grid independence, don't worry about anything. Just do an arbitrary. See, CFD or FEM or these tools are always based on iterative process. So you always keep on refining many times. Okay, and for that you need to have a lot of practice. It's not like that once you create a model that you cannot delete it and make it further. So it's like as I said yesterday also, it's CFD is or any tool for that matter is like learning driving. Okay, so even if I tell you if you go for driving and the person who the trainer will tell you this is the brake, this is the clutch, and this is accelerator and handle. It's not, you cannot become a expert driver from the day one, even if you know what is what. So what will happen is, over a period of time, by doing same practice, braking, then changing the gear, then applying suitable acceleration, it's not one day, it takes months to do the same thing, applying brakes, clutch, changing the gear and changing the handle. These are very 3-4 basic stuff. It looks so simple, but when those who have learned driving, those know driving, especially for me, it was a very nightmare stuff. I thought I can learn within few days, but anything which is skill based, Theory, it's not like giving a theory exam. If you read and give theory and solve the problem and get the grade. This is a skill-based learning. Be it a software, learning a software or a CFD, or be it learning a driving. So unless you practice and do a lot of mistakes, you will never become a good a CFD person. Okay, so don't worry about you may have spent a lot of time in meshing, and you have spent a lot of time in applying boundary conditions. Don't worry. If it requires, go and do a lot of further refinement, as I suggested in some previous lecture. And it doesn't matter how many hours you watch the video of, let's say, driving. If you want a good driver, one can go in the YouTube. A lot of videos are there. You should drive like this, apply brakes. But unless you sit on the driving seat and do yourself, you can never learn. Okay. So CFD is also learning a CFD, or for that matter, any other tool. It has to be a continuous and process. It's actually repetitive. Like learning driving, it's only nothing but repetition. In driving, is nothing like just except applying this brake and clutch and acceleration and handle. What else you are doing there? They are doing, and this itself, it takes us months, isn't it? Just imagine. So similarly, these tools also, you have to do a lot of hit and trial. Lot of times you have to delete it, do something crazy stuff. Only then, after a period of time, you will become expert. But unfortunately, these tools are in such, it is taught in such a way that it is such a big rocket science that unless you become a good programming, programming language, that you should not be learning this. This is not. See, most of our life, I am using a laptop, let's say. I don't know what is happening inside the laptop, how this i7, i9 works. As long as it doesn't hang and it works best, I don't bother whether the fan is running or not. Similarly, I use a mobile. Does it matter I know the coding of Android or not? As long as I know how to use apps in a proper way, as long as it doesn't hang or I don't misuse it, then it doesn't matter. We don't do any coding. For example, we drive bikes and car. Do we know how to develop an engine? No, but yes, some basic stuff. It's not a black box kind of thing that you put X and will get Y. Basic thing, as I suggested, as I told in my previous lecture, those basic things has to be known. That these are the equation, these are the basic things you should take care of to get a correct result. Once you done, then you can be a good. You can be very good researcher engineer. No need to have a very hardcore CFD coding is not required, because the tools have become so easy nowadays that I'm going to show you a video. I have never. I took that video few days back only. See, solid modeling, for example. We teach engineering student that how to make a hollow cylinder. Then you have to design, extrude, and all things. This is taught in engineering. Few days back, I taught the same. I thought, okay, let me teach this process. There was a online class of my son. He's in class 2. And there is a concept of 3D cylinder, cuboid. So earlier in one class, he studied circle, oval shape, and all things. In the second class, in this class, there is a concept of solids object, 3D objects, like cylinder, sphere. So I taught him one, which I teach my student here, how to draw this cylinder. You will not believe that he was doing so fluently. Okay, I don't know whether that video is there with me or not, but if I will share, you will just, and it's not rocket science. Remember, it's not that I'm sharing this just because to show that whether my son is brilliant or not. It's not about brilliant. It's about the teacher who brings in the new knowledge to the student. Student are not at fault of not learning these things, or because they depend upon the teacher who brings in the new knowledge. The whole responsibility lies on a good teacher. So if a good teacher is experienced enough, he can teach in a very complex subject in a very simple way. Okay, and certain things which are the concept which are not easy to grab also, students are able to see. Let me show you that video. Just it's only 20-second video. Just I'm getting a call.
Sir, you are not audible.
सर आपका माइक बंद है.
हाँ, ठीक है. अभी सुनाई दे रहा है?
Okay, sir.
Yes, sir.
अभी कुछ दिख रहा है वीडियो? कुछ दिख रहा है मेरा?
Yes, sir.
Okay, so see how this is a class 2 student, the 30-second video. Okay, the concept which we teach solid modeling in engineering, that can be taught in early stages of education. So what I mean to say is here that we no need to stay or wait for student to learn certain things when they come to the engineering colleges. Now see, I taught him how to design. He is also a tech savvy person, but see, he first draws, okay, a concentric cylinder. Okay, is he drawing a hollow cylinder? Okay, and if you drag a surface, it will become a solid cylinder. And I gave him assignment to make one hollow cylinder. Okay, and using this software to dragging to make a hollow cylinder. See, now he is able to design a hollow cylinder. Even today, if you ask even a 8, 9, 10 class student to what is a hollow cylinder, how to design, he'll first confuse with the question. So what I want to show is certain things like CFD and this modeling. Even today in engineering, even in IITs, it has been not introduced to that level where it is considered as something special, something difficult, something different. Then so mostly we teach theory without dealing with more of a hands-on or computer related techniques. Very few places it's happening. Some institutes are doing in a very big way, but still we are lacking in this kind of education. So even for that matter, CAB also, it is a matter of, as I said, skill. So it should be, even today, I don't know any institute, if somebody knows that this modeling is a compulsory course. This course is taught only after, let's say, when the student reaches final semester, where it is taught as an elective. In between, some student want to do project, it is left to him also. He will just spend some time here and there in YouTube, some tutorials, and somehow he will do something. But they lack understanding of the system, because they have never been introduced this concept of modeling and FEM and CFD in the early stages of their, for example, if they are taught in the second semester, for example, or the first semester they join design modeling, and then the next semester, then they can do a lot of design interpretation. because the students are very curious in learning new things. So if the concept is introduced, they can really do wonders. In a sense, they will come with a lot of new design concepts, which, and it may result finally into startups in the company, and also some innovation in patent filing. That has to change. That has to change. And believe me, this is not that difficult, as I said. And to make it easy, but for the teacher has to become well versed. And for that, we need to spend more time first ourselves in learning, because we never so old to learn anything new. But things as I see that we don't come out of our comfort zone. है ना, जो हम जानते हैं lifelong, mostly it's not true for everyone, but mostly we tend to teach the same thing what we know. Doesn't matter, of course, syllabus में whatever is there in the syllabus, we hardly bother to learn something new, come out of our comfort zone and teach. So we prefer to teach only things, whatever material you have already developed, and keep on teaching lifelong. But that way, so it is injustice to the students. Okay. Anyway, so this one, as I said, just I'll finish this. I have only. Okay, so this one I will I'll show you how to just the same process. The process is that first of all you should break the surface. I don't know whether you can, if it is visible or not. See here, I have deliberately based upon the first simulation. So first time simulation, it says like the flow will be like this. Okay, then next step should be to come back again to the design part and break the surface depending upon your flow behavior. So here there is a lot of recirculation flow, and the flow velocity is very small, almost, see blue color, it says of order of nearly zero in both this region, and the maximum velocity is seen near this region. Okay, the central region. So the second iteration of this will be, so what I should do if I do the modeling. So this region, so I have cut the surface with some this in such a way that I can select this region. Okay, and I will assign this region as a let's say a very fine mesh 1. Sorry. So I assign this region. Okay, and rest it can be a little larger also. Okay, so now this region is highly refined, though I've taken highly refined in the sense one element size, but it may be a little larger also, because it will, but anyway it's 2D, so that doesn't matter. It will be hardly few thousand mesh. And here I have put a very coarse mesh here. Okay, now one mistake also I'm doing here is, since there is a wall near the wall, and there is also some higher velocity was seen in both the, so this mesh is also not that correct. So what I'll do is I'll reject it, and I will refine this region with not fit one. So maybe this region with let's say a little higher mesh size. Okay, because these are near the boundary, so shear stresses is likely to be high there. Okay, can assign. Okay, so and then the rest of the region, maybe around this region I have not refined. Just in case also you want to control, also you can assign the proper mesh size. Then you can return and you can mesh. And then if you do this simulation, then it will be perfectly fine. So I have refined a bit. Of course, ideally you should be applying the bound layer mesh, prism layer mesh, which I showed in the pipe. But since it is not that, you can define it a little bit, and also you can break the surface in such a way that, though I have taken a very larger thickness, so you can minimize that region. So this is where CFD modeling is done. Okay. So before I go, next one more feature I want to tell to all of you, that many time in many situations. So any question before I go to a little more interesting stuff? We call it reverse engineering. Okay. So before I go, I hope it is clear with everyone, or any doubt. It's the same stuff which I told earlier also. Okay, so now CFD is not only for doing this modeling of the current problem. Also, you can get the you can use the CFD for reverse engineering. So reverse engineering, I hope you must be having idea what is reverse engineering and where it is used. Ideally, in engineering courses, it is hardly taught. But industry, most of the industry thrive on reverse engineering. So let me explain what is reverse engineering. For example, let's say you want to let's say develop your own car, for example. Okay, and you want to find out what is the lift and drag in your car compared to the lift and drag of your competitor. Or for example, you want to find out the flow around the engine in your design compared to the flow around your engine or the cooling behavior in the competitor car. So as you know, to do CFD, you should be having a design first. But design is the only what you call prized material, or very important or confidential material any industry is having. Okay, though, so if you start doesn't matter what kind of industry you start, if you ask the company that you need a design to for so and so, you will never get. No industry, doesn't matter what may come, they will give you internship, they will give you placement, everything. But if you ask the design, no industry will give. Now the question is, if you cannot do the design, they will not get design, then how will you get the design? Okay, the best way to reverse engineer, in a sense, draw the CAD model of the existing model in such by some scanning technology. So if you search in the YouTube, the 3D scanners nowadays are coming with a few thousands. They will scan the entire model and generate the 3D CAD. But you can, there are also been technology come, which I teach my students, that without using any 3D scanner, you can have you can generate the 3D CAD. If you have a mobile, your smartphone, that is enough. If there is a car outside, within half an hour, we should be able to generate its CAD. Then how it's possible? See, how the 3D scanner work is, they just take a snapshot of pictures, some 30-40 pictures in different direction, and they will do stitching. Ideally I should have इसमें मेरे पास टाइम नहीं है, तो मैं उसको आधे घंटा 1 घंटा के अंदर मैं बहुत अच्छी तरह समझाता हूँ using software, that how to stitch the surfaces to get a 3D CAD. Okay, so that is called a part of a reverse engineering. So once you get the CAD, okay, by stitching all those images, then though that comes in the form of a STL, stereolithographic triangulation form. Then you can do the post processing on that design and do the modeling. Okay, and for example, let's say if you want to do the some FEM or CFD of, let's say, this teeth, You cannot, with computer, it's virtually impossible to get it dimension. You cannot measure dimension and all the contours and exact dimension is very difficult. Even if you want to design, you cannot design. So what we do, we by scanning it, we generate the 3D model. Then once 3D model there, you apply various boundary conditions, do some pre-processing, and you can do the CFD of such design. In industry, you used to do a lot of this kind of analysis. For example, I was working in a TVS motor company. So when we used to develop the engine, sometimes our engine used to get overheated. And when you compare with the engine with the competitor, their engine are relatively cooled. So we will just break our head why our engine is getting overheated, why their engine is not getting overheated. So what you should do, you will take the engine of Honda or Bajaj, take it to scanning room, you will scan it, okay, generate the 3D CAD. After 3D CAD, do some pre-processing, which I'm going to tell how to do that, and then do the modeling. And also you do the modeling of our own design. Since you have already designed, then apply same boundary condition. And you used to see sometimes that, oh, they have given some special feature for air passage throughout the inside the engine, which we have not given. So then compared to the design, we used to play around then around this similar design, that those features are there. Then first we'll to implement in our engine, we'll first look over, you will search that whether they have filed the patent or not. If they have filed a patent, then you will just modify our design in such way that it will not infringe their patent, and then do further modification. This is how even every industry, it doesn't matter which industry you go, starting from jewelry to aeroplane makers, all industry having a section called reverse engineering section, where their only job is to compare the features and find any innovative features your computer has introduced, any new material, new design, by doing reverse engineering. That is otherwise, without reverse engineering, no industry can survive, because we learn from others design and try to bring in new feature. Okay, and even this the one more way, let's say we do also CFD of, if you want to do FEM or CFD inside the body, for example, your let's say your backbone. Okay, so you know that if you do the MRI scanning, I hope you have gone inside the MRI scanning machine. Those who have gone, they will realize it's a highly scary experience. So it will make sound like ghost movies, and it will do the slicing, slice by slice. It will take the images. You can see here. You can see these images. The contour. Okay, and then you can do some specialized use software to stitches to spine circle. Then it will make a line into nodes, and then convert these nodes into mesh. So finally, your a simple MRI scan can be converted into a proper mesh. Okay, initially this, since you are doing this with some special technique, the mesh will not be good, because a lot of bad quality element will be there, which I'm going to show you, and then do some optimization. I'll show you how that is also done to get a proper size of or quality of mesh. Okay, so the reverse engineering is one of the important aspects in any industry. So to deal with, there is a special technique to do the pre-processing. Okay, so let me show you one example. Let me close this one. So this is also not needed. So I'll import that just to show you the concept of What happened? Closed. Then after that, I'll take some. I'll also talk about this scale analysis, which is one of my favorite subject. Okay, so I have imported here. Now see, this is one of the car. Is my screen visible?
Yes, sir.
Okay, so you can see this is the scan data. So if you scan it, and scan in the sense you have the stitched lot of images into a 3D model. Then how stitching is done, I'm not going to cover that. That is also very interesting. Then how, if you have a camera, you can generate any 3D model without any purchasing high costly equipment. Okay, so see, I just zoom in a little bit. You will see the as I discussed, the quality of mesh. There's no there's no quality. Forget about this, and it's so bad mesh that you simply cannot actually go and simply create a wind tunnel and do the post processing and modeling, just because these elements size, that aspect ratio and angle is gone out of the limit. Okay, so this design is highly rough mesh. Let me check the mesh quality, and you will get only this one. When you stitch a surface, this is called a triangulation. STL models work on stitching a lot of nodes and then convert it into triangle. So this is a triangle to make or FEM model or the element itself to create a surface. Now from this you can again go to get the exact or nearly exact model. You can extract the surface information from this mesh information. Okay, so this is how you can go. So start with the design, physical design, scan it, stitch it, get it STL. Then from STL, you this mesh model, you can get the surface model. So you can get the CAD model, basically the design, which industry, any industry will never give you. Okay, so if I see the quality index, okay, so almost see the 50% warpage, skew, let me all the things. So the almost 50%, see, don't get carried away by this 0, 0, 0, 0, as I said. If you calculate the in AC the proper way, there are a lot of other features, because it's showing 0, because in millions divided by some 0, it's now see the 50% element is now failed because of the aspect ratio. Aspect ratio in the sense their length is very large, 1:, in terms of 1:50. Ideally, you prefer 1:4 or 1:5 in some sense. Now, if you go on repairing this one, okay, it's a very job. The process we involve, we do is we create a new wrap mesh along the surface. We'll just create an envelope of mesh. That mesh will be better to some extent. Okay, so what we do with this first, so before we go for its giving the wrapping, you should know what is the total dimension of the model. Okay, So if you measure the distance, one model and the distance here, so it's showing 100. So ideally the length of a car is how much? This is a Mercedes car. So it will be, assume this is 100, so it is in mm. It is about 4 meter, I think, not more than 4 meter. So it will be 4000 mm. Okay, so and remember, this is one more step. Whenever you do the mesh generation for any geometry, you should know what is the mesh, your geometry, the XYZ of the dimension of the model. Only then you will decide the. So here, you can scale this model. First of all, when you import in any software, always look on the dimension. So if it is, let's say 100, so about 100. So what should I do to make it 4000 by 400? 400 times, if I enlarge it, so it will come as a 4000. Okay, so just I will the process what is involved is to scale it. Okay, so I'll select any node. Okay, and informally I'll by 100 scale it. Sorry. So I selected the model. I selected one node as origin. So I scaled it by 400 times. So I have enlarged it by 400 times. So my now model is perfect. This is the first step. Anywhere when you do in the CFD, it has to be done that way. Now you go on creating a new mesh. Okay. So let me show you how you can wrap it. Okay. So there is and this feature is not is in all software. Okay, this is called shrink wrapping. Okay, so this is the component. Okay, it's a loose wrap. There are two kind of wrapping: loose wrap and tight wrap. Okay, let me select an element size of let's say 80. Okay, and say mesh. Okay, so what it will do is it will. I think I have chosen a very small mesh. It's taking some time. So it will basically you can actually patch the holes automatically. No need to do manually. Also, you can generate the solid mesh once you satisfy with the mesh quality and others. So I think I have taken a 80 mesh size. I should have taken a little larger. So it's taking time. Only 10%. So in tight, in the loose wrap, it will just be loosely fitting along the surface, and if you keep on improving the mesh or reducing mesh size, it will slowly it will approach the actual design. Okay, and the tight wrap, it will from the beginning itself it will try to fix the each and every contour of your original design with the new mesh size. Okay, so it's taking time because the mesh size is though it is 80, so it was 4000. So I should have ideally taken 200 to start with, 200, 250, and then but then it's taking more and more time. I hope some of you might have already done this kind of analysis. So as a part of the course, when I teach, I give them example assignment. The student will have to go outside, take any design or car. Okay, and the next day they have to show the CFD model of that car. So they will go all take their mobile, and there are some guidelines how to take pictures of that design. So if there's a glasses, so you cannot take a image of a glass properly. So you put some feature curves, make a cross mark, or put a on the glass. You can put a what they call newspaper. Okay, so introduce some additional features so that the camera can actually identify while stitching the design. So I think it's done. I don't know why. Okay. Now see, I have taken a very fine mesh. Now just compare the design. Let me come back. Okay, so the red one was the new one, and this was my original design. Okay, see how bad quality it was as I discussed. Let's see, this is a new design. Okay, this is a perfectly square triangle, or and the if you calculate this, its quality will be much better. Okay, without any error. It's a fully closed volume. Okay, and it has captured each and every details with better quality mesh. Okay, so and if you feel that this mesh size is also not proper, then you can go and further refine. Now I have taken a 80 element size. Maybe you can start with element with 200, depending upon the your resources. 200, then you keep on increasing 150, then 150, or 20, all those things, as long as you are satisfied. For here, you can click both the design simultaneously and see where it is not matching. So let's see here near the windows, it does not capture, or nearly captured, but still some features are not captured. So if you think it is sufficient, it's fine. So now next time you can change the mesh size and make it much more refined. So this one, so this our new mesh becomes better to do further analysis on this, and you can also extract the geometry from this surface, find this your mesh. So once you get geometry, you can bring into the export it as a IGS file or any other format, and bring into any proper CAD software like SolidWorks or Pro Engineer, and do further modification. So without getting and this is now somebody can ask whether it is legal, because you are actually dealing with the design of a third-party company without their permission. Anyone? Is it legal to do? क्या लगता है आप लोग को?
No,
No,
sir,
sir.
this is not legal.
This is not legal?
No, sir.
Okay. So what do you think is illegal?
जब तक उनके एम्प्लॉय नहीं है उनकी डिजाइन तो नहीं ले सकते हम लोग.
Okay. Okay. I'll explain the legal and ethical term. Anybody, what you think? Is it legal to do this reverse engineering without their permission? In legal term.
So it is legal because we are not selling it.
Okay. Okay, good. You are to the point. So because you are not selling it, but anyway you are going to make your design.
But we are using it for our design purpose. So the base is this, no?
But we are using it for education purpose only. We are not selling it.
No, okay, forget about, suppose you are in industry. Okay, here one can say that you are using for education, and anyway it's not going to harm their business and all things. It's fine. Suppose you are in the industry and you are doing the analysis of some of your computer in the industry. So is that legal? If that is legal, illegal, then here also become the same rule will apply here also. No?
Sir, if it is already provided in open domain, then I think so it is legal.
Okay, see, the design is not provided in open domain because
Okay.
only product is available. In CAD model, I'll tell you one instance in my company. The design is so critical for any company that they will not hesitate to take extreme action on an employee which actually violate their rule. See what happened. One of my colleague, when I joined there in TVS Motor Company, so one of my colleague was doing a master after BTech. He was there for quite a long time. So he wanted to do his masters by himself privately. So he joined one institute called MS Ramaiya. I don't know whether you are aware of that. Near Bangalore. In Bangalore, there is near IISc, Indian of Science, where I registered for a PhD. I did my PhD there. Just beside that IISc, there is one institute called MS Ramaiya. And my friend, my colleague, actually registered for a master degree in that institute, MS Ramaiya. And since he was working in industry for quite some time, so his project was related to what he was doing. Okay. And one day, what he did as a part of his project, while being in the company inside, he attached some design, and he sent as an attachment from his official mail ID in the company to his Gmail ID. No, in our company, actually, that accessing a Gmail inside the company was not allowed, and accessing the company email ID outside the company was not allowed. So the only way to get the design is to send from your the company email ID to your Gmail ID, so that when you go outside or home, you can actually download it for whatever purpose you want. So he actually sent it so that he can use some for your thesis. And in industry, the security is they're so vigilant that they will scan each and every outgoing mail. There's so much of what we call so much of stringent control of these resources. They're not allowed to bring any pen drive. They'll not allow you to use most of the websites. Some companies are blocked. They will not allow you to use private email, all the things. So he sent, and immediately he was caught by the IT department. Okay, he was called. The moment he was detected, he was called in the HR office, and he was asked to give explanation. By the evening, everything was ready, and he was fired. He explained a lot that he just sent a simple design so that he can use it for thesis, but industry didn't listen him. He was fired by the evening. Morning he was caught, evening he was gone. You can imagine the level of how the confidential the designs are. And for that matter, let's say we have already, you must have heard that there is a collaboration of let's say Maruti Suzuki. So Suzuki is a partner from Japan, and Maruti is a Indian name. So Maruti Suzuki is a combination of two brands, and Maruti provides technology to Suzuki provides technology to Maruti. That's what you have heard. But do you know, in the name of technology, what Maruti gets? Anyone?
No, sir.
Yes. Anybody? आप बताता हूँ कि टेक्नोलॉजी में होता क्या है वो? Any idea? See, in the name of technology, the Suzuki gives 2D drawing, two-dimensional drawing of different parts, where Suzuki can give orders to the local vendors to supply that parts, and later they assemble it and sell it. समझ में आ रहा है क्या बोलना चाह रहा हूँ? What the technology is all about? It's a simple 2D drawing. आप line diagram देखो ना, you have studied in your first year engineering this drawing. That's simply line diagram, nothing else. And to get this 2D drawing, you have to start from a 3D design, do all this kind of modeling, CFD, FEM, 1D modeling. Then you go make a prototype, do testing. After testing, your design is, again keep you, as I said in the beginning of my first lecture, that once prototype is done, then if there is a failure, come back to design. So once the design is fixed, the Suzuki will convert this 3D design into 2D design. So nowadays in software, this feature is become very easy. So if you have a 3D design, just click convert to 2D, it will convert into 2D design, different projections. And that 2D drawings will be given to the Maruti. Maruti will use the 2D drawing to supply, to give to the local vendors. Some will prepare carburetors, some will prepare handles, some will make seat belts, some will make all things. And they will later on assemble it in the name of certain brand. They will have some quality checks and they'll sell it. Okay, so this design is so vital that no industry will share, because at the end of the day, it is the design only, no? Doesn't matter what kind of research you do with CFD and FEM. As I said, it should give you a way to take a decision whether you change the design or not. It's only the design. It doesn't matter how, whether there is a reverse flow or this contour, that contour, shear stress, you change the design. As simple as that. So Suzuki will change the design after a lot of R&D, and they will give it to Maruti, and they have a tie-up that for entire revenue they will take 5 to 10% or 15%. So if let's say 100 crore generated, 15-20 crore will go to the Suzuki directly. So in the name of technology, at the end of the day, it's a design. अब समझ में आ रहा है ना मैं जो बता रहा हूँ, it's only a design, as simple as that, nothing else. Okay, then that design here, as I said, whether it's legal or not, let us come back to the original point. That see, even it doesn't matter where you do. Let's say in industry we do reverse engineering. So as long as you are not infringing their design, it means there are certain features which they have incorporated in design. As long as you are not copying exactly in our design, it's fine. It's perfectly legal to study or dissect somebody else's design, what kind of material they're using, what kind of design they are using, why their product is so lighter, why their product is more better. It's always legal to inspect, provided you don't infringe on their intellectual property patents or they might have filed. You keep on and modify it. You just understand their technology, what they have done. Nobody will give you what and why they have made so and so changes, why they have provided. So we used to ask a lot of questions 5 times. Our boss will tell you ask 5 times questions. Why has been changed. Most of the time, 80% of the knowledge which there in the computer design, you will get it by simply doing proper inspection. 80% of the problem which you see can be proper scrutiny can solve your own problem. Only this 20% additional which is left, you need to do hard work and R&D. Okay, and so 80%, 80-20 rules we used to call in the industry. So the 80% effort is needed to solve the last 20% of the problem. Okay, and if an industry who is willing to go to work hard to solve the last 20%, they are the winner. So most of the design and R&D and training is being money is spent in that last 20% problems. You design a car, most of the time 80% you will be bang on the target. The only 20% failures you will see because you have to spend some additional time and money. So if you get a design, you're doing a reverse engineering is legal, provided you don't infringe on their intellectual property design. अलग से बनाओ, अलग से change करो, but it's perfectly legal to study. So from here, once you get the design, okay, since I have to use a very fine mesh, I can extract the geometry. Okay, so I can extract this surface. I'm not going to this. Let me show you the command. If you see clearly, Any command is visible? क्या दिख रहा है? आप थोड़ा देखिए ध्यान से. I hope it is visible. Very small one. Yellow color pop up हुआ है. क्या दिख रहा है? कोई बोलेगा उधर से कोई फीडबैक? कुछ दिख रहा है? क्या लिखा हुआ?
From FE.
हाँ.
FE.
Yes. FE. It means
FE.
you get the design. So I have clicked here on the surfaces. So now I want to generate a surface from the finite element models. Basically, these are the elements. Doesn't matter we use in CFD or FEM. Ultimately, it's a finite element modeling. So this I can extract the surface from the finite element model. Geometry. I can extract the geometry as it is. दिख रहा है आपको? Let me see. I'll make it little less complex. Okay. In a very bad way, so it will not be correct. So surface complexity, if I will complexity I'll reduce. Okay. Select. I assume my system should not hang. So it will go on to extract this surface. क्या वो hang हो गया? It's not responding. Okay, so I will have to kill that process. So from this geometry, this finite element model, it will extract the surface, and I will export this surface, as I said, to a third-party software in a sense, solid modeling, and then do further processing in the design, just in case you want to do further studies or some modification or something like that. So ये आपका पार्ट थोड़ा सा क्लियर हुआ? मैं जो बताना चाह रहा हूँ. Any question you would like to ask before I move? Any question on this part? FEM model. Okay, so I hope it is clear. So this part should also be taught in the academics. In a sense, this is virtually forget about this modeling through reverse engineering. Even this concept reverse engineering is not taught in that big level. So I always prefer that our course curriculum should be revamped. What industry need? Ultimately, our aim, you are producing engineer for what and for whom? They should go and work in industry. So what industry is doing, we are basically far away. So when I joined first time after my industrial instinct, so I worked about 6 years there. Then I thought I was little bored in a sense कि यही सब बहुत कुछ सीखने को मिला. So initially 3-4 years it was like what I say, what is do, it is always new because I have never seen this world in academia. Even I did my PhD from one of the best college, but my entire 4 years of research over in just one 2D model. 2D, I just created a 2D model. Okay, I developed some navigation equation code, and I got my PhD is over. But when I went to industry, there nobody asked what I did in my PhD, how many publications I have. No, nothing. Once you go there, for them it's all business. Okay, they are going to launch the product next month. Please tell in what way you can solve their problem, and very quickly. They will not stay for, as I said, months and years for us. And this is one of the reasons they are looking for those engineers who have some prior experience. This kind of experience is needed. Otherwise, what happens is, let's say you are producing graduates and they go to industry. It takes for them years to give proper training for this is one aspect of research. There are a lot of many things which they need to be told during their engineering curriculum, but nothing happens. So when the industry take, they spend 2 to 3 years on an average for what I call in giving them training so that they can be really contribute to the company. But the problem is by the time 2 to 3 years down the line, okay, since that graduate didn't know anything before joining, after 3 years he now knew almost sufficient stuff, so he should start delivering for the company. But the problem is, after 3 years, he now thinks that he knows now more, he should be paid more. So instead of working in the same company, he start making his biodata CV to jump the next company. And because of the training given here, he joins other company with some few percentage hike in the salary. Now the question is, why the industry will hire the fresher? If that is the case, 3 years of time is spent in money into giving him training. After 3 years, he leaves the company. So this is the one of the reasons the industry want graduates who are little exposed to certain things, industrial processes and the design and the modeling, so that it takes a very little time for them to grasp the concept there, and they start maybe around a few months of training, they can start delivering. And this is one of the reasons that 80% of the graduate, if you search in the internet, it's written that 80% of the graduates are not even employable directly by the company because they have no exposure. They are good in solving the problems of textbook problems, but can they solve a real problem? They cannot think that way, or they have not been taught. So as I said, it's not the problem with the student. It is the problem with the we faculty, that what we teach them. And most of us, we have failed in adopting the new technology, new curriculum, innovative design. We are still stuck with 70s and 80s kind of curriculum. So wherever there is forum, here I try to change, I try to teach. But for me also, it's a Herculean task to change the mindset of other. It's not that easy, because if I'm delivering the same stuff year and year and year, then it's very difficult to mold someone to please come out of those things and teach something new. It's also very tough. So unless I have a very I don't know, it's an innovative idea to change this mindset. Okay, and many people, you have a faculty group here, so I propose that idea. But again, many people will not like it. In a sense, I said that we in government, we get a lot of money. So it's like a huge money. We do something 10%, we get 100%. Salary ka koi isme match nahi hai. But are we delivering? Are we justifying such huge salary? So what I suggest is, we see every year we used to get increment. We get, as a government servant, we get every 6 months we get hike, increment. For what? Are we learning something new? Are we teaching something new? Or for what we are getting 3% every 6 months? So in a year, 6% to आपका हमारा hike तो पक्का है. Apart from this dearness allowance or bhatta जो मिलता है, so the huge money being pumped every year. But you are not teaching any new courses. Same course what I used to teach in 70s, 80s, it is being taught. एक बार मेरा course बन गया, चलते रहा. So what I believe, just a suggestion, maybe that it should be linked to our teaching. The hike should be linked to our teaching. Nothing else. So those who, and it should be all elective courses. Those who can get more and more students, उनका ही hike मिलेगा. Those who don't get any student will register a course by paying money. So let's say I offer a course, one course, student will be thinking that whether should I register a course, because they have to pay the money. And any faculty who cannot attract that much student over a period of time, that course will vanish. Only some competitive courses which is more relevant will be there. So more student will come, they will pay money, and only those faculty will get the increment. Salary आपको मिलता रहेगा, लेकिन increment नहीं मिलेगा जब तक आप learn something more relevant for the student to learn, more relevant which industry need. Otherwise एक बार हम लोग को सरकारी नौकरी मिल जाता है तो अब कौन हम लोग को निकालेगा? लर्न करो चाहे मत करो, ये तो एटीट्यूड है हमारा एंटायर गवर्नमेंट ऑर्गेनाइजेशन में यही है. तो unless we change our mindset, things will not going to change, and it has to be in a big way, linked somehow with the money and promotion. That so if I don't learn, I don't get hike, no promotion, as simple as that. Maybe if today it may look a little awkward, but in future things will be not that, because in the age of privatization, the only way to improve it to privatize. It cannot, though it's my personal view, so one might also differ, but I think in future it's required. So we should be accountable to what we do and teach to the student. So it's not the student's fault, I believe. I saw one video where a 2-class student can learn this solid modeling. It's just because that is not a rocket science, or it's not because that student is any student can learn, provided the teacher who teach should also know enough first, as simple as that. Okay, so I think I have taken a lot of time. So any question before I stop, or maybe?
Any question? Any doubt?
Sir,
Yes.
Actually, I am doing an analysis of a wind turbine.
Okay.
So, sir, I have seen a video on YouTube. There, in the analysis, they are taking two enclosed surfaces. First, for inside the first surface, in which we enclose the turbine, and then the wind tunnel. So, what is the reason of taking the two surfaces or two bodies for simulating?
Okay, okay. So that's a good question. Let me. I think ये stuck हो गया है, इसको फिल करना पड़ेगा. I'll show with this model. Okay. Now see, let me open this model. Exactly, they ask the same question in, let's say, in the first class. Did you attended my the first last evening class?
Yes, sir. Yes, sir. I have attended.
I took one example of a, let's say, sphere. Okay, and I want to, let's say, do this simulation of a flow over a sphere, like your problem, flow over a turbine, right? That's what the question is. Assume that sphere is a turbine. So CFD will look for a closed volume. Okay, now let me come to this PPT. See this one. Okay, I for the time being, assume that this box is a closed volume. Okay.
Okay.
And this car has to be also a closed volume. So when you do the volume, your object is to do the exterior modeling. Okay. In a sense, you want to put the mesh here. है ना? यहाँ पर अंदर put. ये कार के अंदर नहीं होना चाहिए. So basically, when flow will come, it will go and pass over the body like this. है ना?
Okay.
So basically what we are doing is, assume करिए जैसे हम लोग बोलते हैं ना, बनाते हैं पैटर्न, बनाते हैं replica when you make a design. So this part, if it is a closed one, will be basically removed from the CFD model. तो when you remove it, इसका replica बन जाएगा, वहां पे surface का खाली सिर्फ अंदर hollow रहेगा, अंदर कुछ नहीं रहेगा. So the CFD will fill up the mesh only inside, not inside. Okay. So CFD you can do the volume machine only that there is in this case there are two volumes. So one volume has to be hollow if there is a one zone, and it has to be closed. Okay. Now the question comes: what if you do, let's say, conjugate heat transfer also inside the body? Then they will have two volumes. One is the volume of the car, which you need to mesh inside the car also, and one mesh inside the cylinder. So earlier, when you don't want to model something inside the car, so it will be only one volume. Then you have to remove the volume. It has to be a closed model. If it's a watertight, or there will be no leakage inside the model. You can have a conjugate heat transfer where you will have two volumes, one volume for solid, one volume for pure volume for the fluid. This is what the algorithm of volume meshing works. I can show you one. If there is a leakage, it will not leakage in a sense. If there is any hole or errors in the surface, you cannot create the volume. Let's say this is the car, and if you want to see flow over the car, then this car has to be a closed one. Only then there will be a flow over the car. So basically, assume if there is the wind tunnel is filled with mud, you are extracting the that portion, taking a portion where the car is there or a turbine is there. So it will create a hollow space. There is no flow. Okay, so it will just flow. It will go move around the. Am I able to make you understand? Or
Yes.
okay.
Any other question? Any other query? Nothing. So, no queries here, sir. So we
Sir.
should.
Yeah.
Yes.
Sir, one more operation we use here, which is called Boolean.
Okay.
So what is the use? We are when we are two enclosure, we are making two enclosures for our analysis, and then in Boolean we subtract from that outer body to that inner body, and then again second Boolean operation we subtract the wind blade from this the second enclosure. So what is the purpose for doing that?
Okay, so see, let me show you some model. Yes. See, as I said, in the case of, let's say, flow over a cylinder. So when you, let's say, we are doing a flow over a cylinder, for example. Okay, let me say this. I think this is the best way to show. Just please hold on. This is the same software my son class 2 student was using. Now let's say, please see this one. So I assume this is a one wind tunnel. Okay, and there is one a cylinder. Okay. Yeah, my screen is visible.
Okay. Yes, sir.
Okay. Now let's say I want to do this simulation flow over the cylinder. I'm not bothered about what is happening inside the cylinder. So say, and my geometry will look like this. Ideally, it is like this. So everywhere there is surface. So what I'll do is, you do this subtract. Boolean in a sense, you just subtract this. You remove this surface. Now I have removed this surface. Basically, so here it is hollow, means white means if there is no surface, it will act as a solid. So the flow will come over this solid and it will deflect.
Okay.
So we are simply removing the region which is act as a contour to deflect the fluid. Okay, so this we are actually doing the subtraction. So the hollow portion will act as a solid. So in your case, you are subtracting the impression 3D design from this 3D model, so that the contour will look like this. It can be anything. Let's say if it's a cylinder, it can be anything also. For example, it can be, for example, let me show you. It can be like triangle also, for example. Okay, and you want to flow this one, you just have to remove this one. You remove this one.
Okay.
Then the flow will come, it will go and slide over. So it can be a blade design or a turbine or whatever, subtract this one. Now, just in case you want to model this also to look, if it is a solid object, you want to see the temperature of this solid blade or whatever. Then in that case, you need to keep it. And then you have to assign an interface condition. So if the outside is a let's say fluid and inside is a let's say solid, and you want to see the temperature, this one is a solid also. So then there has to be a small interface region which you need to define the interface. And you have a more than 2 regions. So earlier it was 1 region, now it has come a solid region. And fluid and solids should connect through an interface. There is a special treatment in CFD to model the interface. So you define the interface, then you can model the inside the object also. If that is not the part, you just subtract it, remove it, the impression. It is currently it is 2D, so it's easy to visualize. Same process is done in the 3D. So in 3D, how we do? If you only keep the external portion and don't mess in the inside, so it is same as this, the same as this. आपको थोड़ा imagine करना होगा. Just imagine if you are sitting in, let's say, in mud, and mud is so dried, and if you are removed from that, your impression will be there. So wherever there will flow, there will be obstruction. It's actually an object to deflect the flow. So like casting में करते ना mold and imprint. So you just, let's say if you want to make a sphere in a brick, so you have to put a replica in the sphere so that it is subtracted later on. So you are doing this simply subtracting that surface away from that volume.
Okay, sir.
Okay.
Okay, sir. Thank you.
Anybody else? Anybody else? Okay. So now it is the time to end the session. Thank you so much, sir. You have delivered 3 lectures. You have delivered very excellent talk on that. And last 3 lectures, we are so happy to hear from you. And you discuss elemental mesh quality. You cover all the features of the software, aspect ratio, RPSQ, Jacobian, etc. You also cover the reverse engineering in CFD. You explain very well all the content and motivate all of us to learn and update ourselves more with new techniques and engineering tools other than theoretical aspects also. So thank you so much, sir. Now I would like to invite Professor Tiwari to give you thanks, sir.
Thank you, Dr. Singh. Actually, I have seen your session here, especially CFD pre-processing technique. You are very well explained what are the surface feature, how is the organizing surface or volume mesh generation, then boundary layer generation technique, mesh refinement, boundary conditions, CFD and reverse engineering, very well explained. Thank you once again for accepting our invitation as a guest speaker. Now on the basis of your demand from the participant side, when this after COVID, we want your session at this place at the IIT. Actually, approach practical session, because I have conducted so many workshops, and all those maximum workshops is on the basis of only the numerical and this part of the procedure and theoretical aspect. But you are covering all the aspect, especially in the how to start at the first principle. Your session is so interesting. So the participants are demanding your session. So after COVID, just I request you for the 2 or 3 days session, especially for you only, just to cover all the aspects in detail.
Yes, sir. Usually what happens, sir, I offer here short-term CFD courses for 1 week, and I rigorous training hands-on, where participants actually they use the model, they develop their own CFD model and run it. It's really a good experience for them. So if you commit, please invite me. Definitely I will come and visit your place.
Okay, sure, sir. Thank you once again.
Okay.
Thanks for joining us, sir. Thank you so much.
So our next session is at 3 p.m. Start at 3 p.m. Dr. A.R. Pal from MNIT Allahabad.
Thank you, sir.
Thank you.
Bye all.